Thank you for coming.
Yeah.
We know Rawson's in the auditorium, so really, thank you for being here.
Really.
Maybe you're in the wrong room.
I'll tell you right now, that's a better talk. Rawson's going to be talking about GraphQL. He knows the thing.
If you leave in the next 20 seconds, we won't be offended.
Yeah.
But
okay. So, who's doing Kubernetes? Who uses Kubernetes? Who's been used by Kubernetes? Like, who feels abused? Yeah, exactly. Okay, I'm just wondering. Like, it's not a particularly great experience out of the box. Okay, well, anyway, we are your hosts today for the next 50 minutes. I'm Josh Long. I work on the Spring team, and Cora also works on the Spring team, and she's
advocacy team.
She's got Kubernetes
familiarity,
certs, and she's smart.
I've heard of it.
Yeah, we're gonna cover a lot of code. It's not the best code, but it's all we got, and it's right here on GitHub. And again, not a message of hope. This could get better, but we'll talk about.
And it will get better. It will get better.
Not in this hour.
Not in this hour.
Definitely not here.
No.
But
later.
Eventually,
yes,
in the way that all things converge towards the heat death of the universe, things will get better in the Kubernetes space, right? Okay, carry on.
Okay, so Bootiful Kubernetes controllers. Yeah. So we're going to talk about Kubernetes controllers, and then we're going to use Spring Boot to write one. So convergence of two worlds. And so this is a tweet, a recent tweet from May. This is Josh's opinion on Kubernetes.
I thought I'd share a screenshot of what I was saying instead of just saying it. So I said this at a DevX UK a few weeks ago, right? Mm-hmm. And I sincerely mean this, and there's a reason.
Got some responses.
Oh, it's going to be too hard for them to see that.
We'll read it.
That's not great. I could, if only. I'm not really practiced in slides.
The slides are my contribution.
They're great.
That's what I did to get here.
But let's see here. Wait. Horizontal, vertical. Okay.
But apparently I didn't do them right.
No, this is me. All me. Can you see that in the back? Probably not. Okay, well, one person responds, well, there is some fundamental truth to it. One key value of Kubernetes is its intent. I'm sure he meant its intent. He speaks French, neutral gender, as an object API, and the fact that the intent is queryable to do the reconciliation loop. In that sense, Kubernetes is the most important API database that happens to use YAML, or abuse YAML, right? And then Brian Grant responds, basically, yes, this is true by design. 30,000 feet view of Kubernetes. What do you think what is that thing on the left?
So there's a database on the left, and a loop on the right doing something about what's in the database.
And then
Brian Grant, a little more than just a database.
Right.
A little more.
Well, no, I think Kubernetes is just a database. There's a whole bunch of other stuff that does interesting stuff, but Kubernetes by itself is just
a database,
a place to store stuff, and something has to make it valuable, right? Like if you apply YAML in a forest and nothing reconciles it, did you actually apply that YAML? That's a philosophical question. It's been in the history books for a long time, and the answer is no, you didn't. So stop complaining. Brian Grant is a Google Cloud person. I don't know. He just says Google Cloud.
Says emeritus.
He is Google Cloud, right? That's him. He is the cloud. And he's also an emeritus for the Kubernetes Steering Committee, the Kubernetes Special Interest Group for Architecture, co-chair, Cloud Native Computing Foundation, TOC, creator of Kubectl-Apply, Customize, KPT, Config as Data, all the reasons that we don't go home on time. It's him. It's him. But anyway, he knows. He knows. It's not just some weirdo in a Spring t-shirt saying nonsense. There's somebody who knows, right? And that does bring up a great point.
Right. So
back to this.
So this is the 30,000 foot view of Kubernetes, where we have a database that says some definition of something that we would like, and then there's a loop that is going to respond to the information that's put into the database. And so those loops come in the form of controllers. So these controllers are programs. They run in a loop. They don't have to even be in Kubernetes. They don't have to be anything special. They don't have to comply to anything, except it's a program that runs in a loop, that gets the stuff in the database, that looks at what's running and looks at what is defined in the database and says, is this the same? And if it's not the same, then what's in the database is what you want. And so I'm going to make that be true on your worker nodes or whatever it is that it's not everything. It has to be a running process, but whatever you wanted, it will create or delete or update. So that's it. That's a controller. And so there are some sort of primitive main controllers that are included. When you install Kubernetes, you have these controllers, a controller for, there's more than this, right? You create pods and things like that. But there are certain controllers that have a combination of characteristics that help you manage use cases for stateless applications or stateful applications. Stateless applications, you can imagine, have certain characteristics for ease of scaling. Others might have an affinity to always run on a particular node. Maybe they maintain a certain identity even if they crash and they come back up. Some are, short running a job that just does what it does and then it stops versus a long running process. So there's all these different characteristics that we can achieve by using these main controllers to request some kind of behavior and have these things run in a loop and deploy what we want from them. But these are fairly low level. They're very functional, but they don't sort of meet the needs to do fancy things that we might want to do and fancy things that would serve your needs as developers, right? So as developers, you might be familiar with using much more sophisticated tools, like these tools that require some kind of persistence and quorum and fancier behavior. And so you can't sort of put these together with just those primitives. So we need to create fancier, more sophisticated controllers with higher level definitions of a structure of an object that we want to store in the database and instantiate on the cluster. And so we create custom controllers. And so here's a list, and you can read about it. Yeah. Josh wrote a whole blog post on this.
They all require interesting coordination. Mm-hmm. And they of course, they're using the other stuff, the lower level stuff, but they need to coordinate that, right? And they need to work in tandem with the control plane of the individual infrastructure, the middleware.
Mm-hmm. And if those are not enough, there's a bunch of very, very smart people who've written products that rely on custom object definitions and the controllers behind them that will continually watch for what you ask for and instantiate it, make it so in the cluster. So, yeah.
This is a fractal, by the way. If you zoom in, there's just more tiles that appear. Believe it or not, it's not what you think. It gets worse.
So we're going to take a step back, and ultimately we're just going to do sort of a hello world or a foo operator demo. Josh is going to code this right in front of you. But we're going to walk through a little bit more sort of the basics of the mechanics of this so that when Josh is doing the coding, you can sort of have this framework in your mind. So first of all, we have to learn how to talk to Kubernetes, right? So if ultimately what you want is an instance of Nginx running, right? That you might say that, but Kubernetes doesn't understand that. So we have to put that in terms that Kubernetes can understand. And so what Kubernetes knows is that what Kubernetes would understand is that you want a pod kind of resource in the cluster that has a container inside of it, and inside of that container is an Nginx process. And you can write that definition. You can express that request in this declarative way using YAML, using JSON, using protobuf. Most of us are familiar with writing YAML for this, but it's not the only syntax that Kubernetes understands. So how do you communicate with Kubernetes? So everything that talks to Kubernetes is going to go through the API server, right? You can't. They might have a database, but you can't go store that request directly to the database. The API server is the only thing that owns the relationship to reading or writing from the database. So you would send a request using any kind of client, maybe the kubectl CLI, for example, to send this request and say, hey, Kubernetes, this is what I want. I want you to, in this case, create this pod. And so what Kubernetes does is it puts it in a database. Most typically etcd. It doesn't have to be etcd, but it stores that definition in the database. And then if you don't have a controller, that's it. The API server and the basics of Kubernetes, and this is why Josh is saying it's just a database without any action behind it, you need something to be asking the API server, hey, is there anything for me to do? I care about pods. Are there any requests related to pods? And then once that program gets the information about, oh, there's a new pod I should create, that program can go and say, in fact, somebody wanted a pod, there is no pod, I will create it, right? So the scheduler is a type of controller as well. The scheduler will check specifically for pods. It'll decide there are certain worker nodes in this cluster, which worker node has the resources to receive this pod. So once that pod has a destination assigned to it, then a process called a kubelet, in this case, the kubelet is a pod controller. It's separate from the other controllers, and it's running on every node. But that kubelet is going to talk to the API server and say, hey, are there any pod definitions that have a node assigned to them that I could start? And so if there are, then the kubelet gets that. And at that point, the kubelet controller is doing something really interesting because it's not actually starting that process in what is Kubernetes proper, but it's going to the container runtime and starting that, right? So different controllers may do different things, right? They might program the network, for example. In this case, it's talking to the it's creating something on the runtime. So they're kind of exceeding the boundaries of what the Kubernetes program properly is, right? So that's what the pod controller is doing. And but if you're talking only about a resource that defines the pod at its most primitive level, there's not a lot of other fancy stuff you can do, right? You can't scale all those pods. You can't maybe manage that scaling, or you can't roll out a change to the pod slowly, a few pods at a time, and check how that's going and manage traffic and things like that. So it makes sense to layer on top of this higher level objects that can add that kind of behavior. So that's where, if we're talking about those main controllers that we saw on one of the initial slides, this is where a deployment might come in, and that would be appropriate if these pods happen to be running these stateless applications and you have the ability to scale them without concern. So in this case, Kubernetes also understands the structure of a deployment, right? These are types of objects, right? In the same way that if you're working in Java, you would define your object class. So it understands what a deployment is, and it stores this request in the database. And so what actually happens in this case is that the deployment controller, which is in this case, the deployment controller is in the controller manager on the control plane by default in Kubernetes, the deployment controller will inquire with the API server and know that there was a request for a new deployment. And so that new deployment, what it does is it creates a replica set. And so what the deployment controller does is it inserts into the database, by way of the API server, it creates a request for a replica set. And that's it. And then the replica set controller is also checking with the API server saying, hey, is there anything for me to do? And as soon as that replica set definition gets inserted into the database, the replica set controller will say, oh, I need to do something. Oh, this is a request for 3 pods. And so then it'll create the request for the pods, and then the pod controller will see that there's a request for 3 pods, and they're scheduled on certain nodes, and so then it will go and start up. So it's kind of like a relay race, right? Every controller is creating something different. And so there's a relationship between this deployment, this replica set, and these 3 pods, right? They're in the same family. And that is managed by ownership. And so there's the simple definition that you would submit to the Kubernetes API server, and then there's extra metadata that the Kubernetes API server is adding to the definition of that object in the database. And one of those pieces of information is this idea of an owner reference. So in this case, you can see the relationship between the pods. The pods are specifying that they are owned by this particular replica set called Nginx deployment. So a very specific one instance. So then the nice thing about this is that if you go and delete the deployment will take care of everything that is owned by the deployment will be deleted. So the replica set will be deleted because of the reference. And then when the replica set is deleted, then the rest is deleted. And it works in the same way, right? The deletion request goes into the database. The controller sees the deletion request. It says, oh, you wanted me to delete something. It exists in the cluster. Let me actually remove it. And the pods eventually will get deleted as well, right? So just recapping that a little bit. So the controller is that program that is constantly checking with the API server to see if there's been any kind of request. Again, create, update, delete, anything. And it compares what does exist in the cluster to what the last request wanted. So it can just be this very simple loop. And so if you imagine that there's these controllers all checking with the API server, that can be a lot of load for the API server. And if you're constantly asking for the records in the database, that's a little too much to expect for the API server to handle. So there's all this sort of machinery under the covers of a client, right? So if you're going to write a controller, you're not going to write everything from the ground up, right? Just as if you're writing a Spring Boot application, you're not going to write. The reason that you use Spring or Spring Boot is that you don't have to write all the mechanisms from the ground up. You want to use some pre-coded libraries. So in the same way, you would use a client to create your controller, and in that client, a lot of this logic is built in to take the load off the API server and to make this whole process more performant. And so there is some concepts. There's a lot more concepts under the covers, but we're just going to mention this idea of a shared informer or a shared index informer, where a controller, if it's managing more than one type of resource, it can get the results from the database, from the API server, store a local cache in the controller process. And so every time it goes and gets a little bit more information, it has a sort of a cached copy of the events that happened for a particular type of resource in its local cache. And that way we don't overload the API server with these requests.
In the memory of the Java process, right?
In the memory of if we're writing a Java controller, in the memory of the Java process, right?
So the informer keeps data. The shared informer can be used by multiple controllers. The shared index informer lets you index into the data by a key.
Right. And so one Java process, so for example, I just installed.
Oh, it worked.
Did it? Yeah. So
wow.
I just went, just so we have an example, I like KPAC. KPAC is the thing that runs on Kubernetes that builds your images for you. So I just went to get their latest release, kubectl apply, and it's a YAML file filled with different definitions of objects. And so you can see that it's creating all of these resource definitions, right? So it's not just pods, but rather KPAC has actually added new structures. So if we do, for example, clear this and do a kubectl API resources, and I'm going to grep for KPAC.
She installed all that like 2 minutes before we started.
Before we took long. That's why we were a minute late.
That's confidence.
And bad planning.
I don't trust anything that much.
All right, so let's make this. And by the way, this kubectl API resources is a really handy command. So I'll just run it again to make the screen clearer. Okay, so KPAC, when I installed KPAC, again, it's not just about these deployment and stateful set, but it actually added these resources. So now I have a builder, or if I want to tell Kubernetes to build a container image for some source code that I have on GitHub, I create an image resource that has its own definition, right? So, but these belong to this kpac.io group, right? So I have a group here, and I have a version of this API, and so these are custom resource definitions. And so behind each of these, there is a controller that says when, as a user, I create a new image resource, the image controller is going to see that I wanted that. And in the case of KPAC, particularly, the controller is then going to create a build for me. And then every build will create a pod to actually build the image, right? So these do leverage lower level resources as things that they own. So, but those are some examples, right?
Very good.
Where's the slides? Is this the slides?
No. Different window.
Hold on. This one. Okay. So, so we talked about shared informers. We saw some examples of resources. So then, so level triggering. So we have a new request in the database for something, and when we say that that the controller is comparing the actual state to the desired state, what does that really mean, right? And it can be implemented in different ways, but as an example, one way is to look at some of the metadata that I'm saying Kubernetes is adding to the resource. Some of that metadata is the generation of that object, and so there's the generation of the definition. So let's say you start with generation 1, and once the controller sees it, there's a status section to that object. And so the controller will say, okay, I've observed generation 1. And then when that definition changes, that generation value in the main definition of the object would become generation 2. So the next time the reconciler runs and it sees, oh, I've observed generation 1, but the definition is generation 2. That means that I have to apply that new definition to the cluster, right? So then that's one way that it can be done. And that means that it doesn't need the whole history of changes. It always knows that this new definition is all the information that it needs. So for example, if you think about a weather report, and a weather person tells you, okay, today is 20 degrees Celsius right now, and then temperature went up by 1 degree, then went down by 3 degrees, and up by 5 degrees. If you don't have all of that information, you can't figure out what temperature it is right now. But instead, if you just say, now it's 20 degrees, now it's 23 degrees, now it's 15 degrees, then you don't need the whole history. So when you don't need the whole history, that's called level triggered. And when you need that whole history, that's called edge triggered. So you can achieve both in Kubernetes, but really this level triggering is the way that most of these are written and the way that we're writing.
Yeah. but there are ways to get there.
Yes, you can do edge triggering as well, getting the deltas and so on.
You have to pack the state in the object somewhere. The observed generation is one way to do it. There's others as well.
Anything else we have to point out here? Anything else to point out here?
No, ma'am.
Okay. So as we said, you can extend Kubernetes. You can create your own resource types, so that object definition, and then you create the controller, or you can actually add a second API server, so that if you create a type, it'll delegate to your API server. There's different ways of adding your own object definitions, but the most basic is to create your own definition, like your object class sort of, and then you write the controller that will know what to do when one of those is requested. So what Josh is going to build for you is an example of writing a foo controller, because a few slides ago I showed you the YAML to create a deployment, and it kind of took up the whole column on the left, so we want to simplify that. So when you want a deployment, actually what we ultimately want is 3 Nginx pods, but we're going to do that through a deployment. So we want a foo object that will create our deployment that is predefined to have 3 Nginx pods in it. And we'll do that by simply allowing a user to specify this very simple definition. So we have to write a foo definition, object definition, and we have to write a foo controller.
Yeah.
And who better to do that than Josh Long?
Well, right on. Thank you. So, good stuff. So now you understand the big picture. And if I'm honest, you're probably most of the way there at this point. The code is, at the moment, more or less a one-to-one translation of these low-level concepts. So we're going to see the code, but I'm not going to lie to you. It's not pretty. What I think needs to happen is there needs to be some sort of higher level sort of framework. And if I only knew a team of engineers that work in the Java space that build frameworks,
Never.
Nope, no one comes to mind. Anyway, maybe one day, but in the meantime, we'll just do it the old-fashioned way. We're going to use the Kubernetes, the official Kubernetes Java client. It's the project, it's the client that gets created and maintained by the Kubernetes team. Now, there's actually another client in the ecosystem that's really good as well, called Fabricate, from the good people over at Red Hat, right? Fabricate is another client, and they both have one thing in common, which is they take the API definitions, the object definitions, from the API server, exposed as Open API Swagger definitions, and they code generate a lot of Java code. I mean, a lot. And so these client libraries have the benefit of being consistent and consistently terrible, right? They are consistent, though, which is something. I suppose if you have to accommodate a lot of anything, I want consistent anything. You know, at least I know how to navigate and move around. So I'm using the official Kubernetes Java client, but having done a lot of work in both, I can tell you the concepts are basically the same. The Java API, because the concepts, the Java code that you're going to see, maps more or less to the concepts in the API server, and then those in turn, when there's custom code, it maps pretty much to the concepts in the Go implementation. So remember, most controllers today are written using Go, which is a language that people have used on purpose. Search me why. I don't know. No idea. But it's a thing you could do with enough sangria. And we're not going to do that. We have Java. Why would we do that? So what we're going to do is we're going to build a new service. I'm going to call this the I'm going to call this the, foo controller. Okay. And there we go. We're going to use Java 17 again because this is just it's just a process. It doesn't matter where it runs. And if you're going to run it, you might as well use a language that likes you as much as you like it, right? So we're going to use Java 17. I need Lombok. I know. I don't really need a reactive web server. I'm just going to bring it in because I want the port to stay open. I want the process to keep running, but don't need that. And that's, native. We want Spring Native. Okay, so that's it for now. We're going to add those bits. Now, this is a lot of code, so I've actually, sorry. The code you saw is on github.com, Kubernetes native Java, controllers 101. You can follow along at home if you like, but I've got this code kind of off in the wings here, so we're going to open this up in the IDE. Here we are, downloads. Get rid of all that. Okay. UAO foo controller.zip. And the first things first, we got to add a few dependencies before we even get started. We'll introduce these dependencies. By the time we're done, you'll see what they all do. But for now, let's just add them to the build. So here's this. Pasting. Okay. So I've added the official Java Spring Boot integration from the official Kubernetes client library, right? So the Kubernetes team builds a Spring Boot auto configuration. but it's not really, it just auto-configures some of the interesting basic stuff that you need, but it doesn't really offer a very nice programming model above and beyond what the low-level stuff is. And I think for good reason, because there is an infinite possibility, there's an infinite realm of things that you could do with a controller, and to more abstract any of that would be to foreclose on the possibility, on some of those possibilities. But that said, I do think there are some use cases for which some abstraction might be very useful. So for now, this is an okay place to start, but it's certainly not the only level of abstraction or granularity that I would recommend. And then these are a set of Spring native hints that I wrote to support turning GraalVM, Fabricate or the Kubernetes Java client bindings into native images. Okay, so you just add that, and they automatically support using Spring Native with GraalVM. Okay, and for these different libraries. So first things first, we're going to write a controller. This controller, the basic definition of the controller is here, right? So we're going to, let me make sure this is imported. Come on. Well, that's not good. Warning. Okay, everything seems fine. Good. So the first thing that we're going to build is a controller, like so. And it's not a Spring Framework controller. It's one of these other ones, right? So which one is it? Probably this one. Actually, let's just try copying and pasting, and we'll introduce as we go. Okay, so it's useful to start with a controller, but the controller is by no means the end of the journey, right? So we're going to build a controller like so. Make the font a little bit smaller. Oh wow, it's all. Oh, here. Let me make the font the background. How do I? Let's see. Sync with the OS. IntelliJ Light.
Much better.
Can you see? Okay. I'm sorry about that. Yeah. The lights are on here. Can we turn off the lights? Imagine being in a movie theater and trying to watch Avengers and all the lights are on. I mean, it's okay. We saved the day this time, but you know, wouldn't be great. Okay. So yeah, extended controller. I think it's this one. We'll see. YOLO. So there we go. So there's our basic controller. The thrust of it is a controller is a thing that we're going to register with the API. The controller needs to. It has a watch. It looks for data coming in on this queue, and it looks for types of v1 foo, which is the type that we're going to code generate to match our YAML database, okay, our YAML API. It's going to resync every 1 second, and there's going to be 2 threads, and we're not going to start doing anything until something called an informer has synced. That is to say, once it's cached its local version of the data. All this to say, it's boilerplate. A lot of this is boilerplate, but what you can already see some key concepts coming out. First of all, there's a Java type called v1 foo. We need that type somewhere. Somebody has to generate that type, and that gets us to our controllers and our CRDs themselves. Okay, so we go here to controllers 101, and do I have Sublime? Oh, Sublime, you sweet Sublime thing, you. So here we go. I have already written. We're not going to write this by hand because we like you. We have already written a custom resource definition. This is an object that describes an object using YAML. YAML has all of the weaknesses of Python and 0 of the benefits. So be super careful when using this, right? This is a terrible way to run a railroad. We are going to define a custom resource definition. It has a name, a package, basically. That'll correspond to our package in our Java code later. We're telling the API that the singular type is called a foo, the plural type is called a foo list, and the kind rather, and then the plural and singular versions look like that, right? So foos and foo. It's namespaced. So this is very common. You create something that exists in a namespace. Some controllers, some CRDs are global, cluster-wide, but in this case, namespaced. Then you have to use OpenAPI v3 schema in YAML inside of the CRD definition, right? And so here we're saying we've got an object called a foo, and that object has, and I'm not kidding, 1 field called name. That's it. That's all I've managed to do here. I was too tired and I went to bed. I refuse to write anymore. That's all this does, is it creates one object with 1 field called name. Basta. That's it. So then So then we need to register that with the database, with the API database. We need to tell the API server, hey, sometimes somebody might want to create a thing that looks like a foo. Here's what that definition looks like. This is the class definition for an object. So you go to this, Kate's, CRDs, you say k apply minus f foo.yaml, yeah? That's going to apply. It might fail because it's already there. Okay, well, whatever. Good. So there it is, right? There's a custom resource definition. It's in the, and so I can say k get CRDs. Kubernetes k is my alias for Kubernetes, okay? And if I look at the CRDs, I can find foos in there. Grep foo. There you go, foos.spring.io. So that's our custom resource definition. We've defined how a class should look, but we haven't defined any instances. And so that I can do by creating a test. Look at that file there. Right? Cat test. So there's my API version, Spring.io v1. The kind is foo. The metadata is demo. The name is demo2. And the spec, again, the one field is just name. Completely pointless, just as simple as it can be, so we can see the machinery of this. Did any of you ever read that book, Bitter EJB, by Bruce Tate, like 20 years ago? It was written before EJB 3 when they were talking about EJB 2, and it had this amazing metaphor that I'll never, ever forget. He talks about having to eat the whole elephant, right? You can't just use a little bit of EJB. If you want to use it, it's thousands of lines of code. EJB 1 and 2. 3 is, of course, a much, much better story. But back then, it was just, you couldn't lightly use it. You either understood everything or you got nothing, right? You had to eat the whole elephant. And I feel like that's kind of where we are in the Kubernetes programming story right now. The ability to extend Kubernetes is at least possible, which is wonderful, and it's possible in a generic cross-platform kind of way, but it does require a lot of elephant sacrifices, and that's bad. So here we are. This is what it means to create a single instance of a foo. But again, once we've created that instance, something needs to respond to that. And so in order to build the code to respond to that, we're going to use code generation to generate Java types that map to the CRD's definition in my API, okay? I'm not going to actually run the code generation. Instead, I'll show you the thing I would have run if I had a lot more time to sit around and wait for this to finish. So you use regen CRD Java, right? This script is actually going to point to a YAML file. This is pointing to the CRD YAML file in my GitHub repository, right? And it creates a directory. Then it runs Docker Gesund. It runs Docker, mounting the Docker socket. Why? I don't know. Who cares? PWD is equal to PWD. Sure. Network host. Why? I don't care. Okay. Anyway, moving on. Finally, here's something that seems vaguely interesting. There's a script in there. Who knew? Who knew? Why would they put the script there? And there's a username and the package. Don't screw this up. You do not screw this up. This has to match oh so perfectly, or you'll never understand what happened. And then just again, just for fun, here's PWD. So 3 PWDs. There it is. Look at that. We're really just doing a great job here. Anyway, that works. Don't ask me why or how. I don't care. I don't even want to run it again. It'll talk to the API server. It'll talk to your API server using that CRD, and it'll generate Java classes, and then you can import that. And so I've already done that. I don't usually come prepared, but here, this time, for you, I've come prepared. So here's the IO Spring, okay, Spring, and models, yeah? So here's these 4 types that it gives me automatically. So let's copy our models to downloads, controllers, source, main, Java. Okay, I'll have to change the packages here myself. So source, main, Java, package io.spring, and models goes inside. Good, and then this controller, we'll just go here. And if there was only a world in which testing these things was easy. Actually, there is. What we just learned about? There's actually a really nice opportunity for test containers here. You can use that to spin up like a lightweight Kubernetes API and then test your code that way. Who knew? I didn't, so we're not going to cover it. But it seems like it could work.
There was a test containers talk at the end of the day.
Oh, yeah, with Oleg Shelejev. Yeah, go see that one. That'll be good. I'm sure it'll be good.
You can ask him about this.
Yeah, he'll love it. He'll love it. Just ask him the questions. Say you're confused. Let's see. Okay, so package, IO Spring models. Are we happy yet, Mr. Controller, Mrs. Controller? Let's see. V1 foo. There we go. Okay. Yeah, is it compiling? I mean, oh, okay. False negatives. IntelliJ thinks it understands the component model. That's a lie. Okay, so here's the types. Yeah. You can see it's very bitter Kubernetes, right? Like I extend this Kubernetes object. I've got these built-in fields like metadata, spec, and status. These are all part of Kubernetes, not part of my API itself. I've got hundreds of lines of code. And again, we have one field of type string. One. That's it. I didn't even do two. Two would have been crazy. We don't have enough RAM. So status, spec, list. Here's the plural, because they couldn't just give you a list of foo. It's actually like a custom type, which is nice. I don't know. This is why we cannot have nice things. You know, look at this. So this is API models, right? This is Open API Swagger stuff. Okay, so there we go. We've got a controller. It clearly needs something called a shared informer factory. It gets that from the Spring Boot autoconfig. Fantastic. We need a shared index informer of type v1 foo. Remember, this is a cached version of the events of the data coming in from the YAML database, the API server. And then we need to create something called a reconciler. This is where our business logic lives. We still haven't gotten to anything that matches our business logic. So let's do that right meow. Actually, I'm just going to copy and paste all the code just to make this time go a little quicker. Because fundamentally, you understand what's happening. Cat foo controller, pb copy. Okay, so paste all that, and then YOLO. Okay, so here we go. Here's our controller. It needs a reconciler. The reconciler is this bit down here. This is the actual business logic. Okay, here we have a lambda. The reconciler contract is super simple. When a request comes in, you provide a result. The result is just a wrapper around a Boolean. They don't just give you a Boolean, though. You can't just return false or true. For some reason, you have to return result with Boolean, true or false. So we have a lambda, and the request gives you only two things. It gives you, if you look at the request, if you look at the contract here, it's a request around a name and a namespace. So this is the name of the object in the cluster, and this is the namespace of the object in the cluster. It doesn't tell you anything else. It doesn't tell you if something was deleted or created or added, or if Kubernetes just woke up and it wants to make sure everything's sane. It doesn't tell you why it's bothering you. You need to inspect the world and say, oh, hey, I've perceived that you have, that something has happened here. It's given me a key that is comprised of the name plus the namespace. That is a key that I can use to access a pointer or reference to this v1 foo. Well, if that v1 foo doesn't exist, then I can imply that maybe it was deleted, right? If I try and get the foo from the database and it doesn't exist, it's deleted. But if I get it and it's there, well, then I have to see if I have to do a sanity check on the state of it, right? So this is where we get into this tedious business logic here, right? So, okay, we say, okay, shared index informer, get indexer, get by key, and the key is the namespace plus the name. Then we see if the foo is null. If it's null, then just return false. It's done. Because we already did what we talked about earlier. We already have owner references. The owner references mean that if you delete the foo, it'll cascade delete the deployments that we want to have created as a result of creating the foo, okay? And then we return false, which means don't re-queue this request. We don't need to process it again. It's fine. Everything went fine. We're done. It doesn't need to be concerned about anymore. Next, we say we're going to create a deployment, right? Assuming that it wasn't deleted, assuming that it was updated, something was updated or deleted. I don't want to create a deployment object, a Java object for deployment by hand. So there's a nice, you can actually just load a deployment YAML here. This is, I can't believe I just said that word. Nice YAML. So let's see, resources. Oh, you have to copy it from here. Copy, source, resources. Let's see, what did we say? Deployment.yaml. pb copy. No. Computers. Okay, so I'm going to create a little file here called deployment.yaml. And this is just it's just a regular deployment, right? But instead of writing, because basically you would have to use Java to create this object programmatically, and I just want a deployment with 3 replicas. I haven't even done anything special, but I'm going to use this. I'm going to create a Java object out of this by literally, I've got a little function here where I call load as YAML. I'm just reading the strings from this resource, reading the strings from the YAML file into memory, and then using YAML.loadAs to turn that YAML into a Java object. Nothing special. Once I have the Java object, I then get the metadata. I change the name to match the name of the foo, and then I add an owner reference to the current foo, right? So I've got a deployment in memory. I haven't registered it with the database. I'm configuring it. I'm like setting up the associations. I'm adding an owner reference for the current foo kind, the current UID, the current name, saying it's a controller, etc. Then I have 2 options. One, I can try and create it, right? I'm assuming it hasn't been created, so I try to create it by calling apps API v1. That's this bit right here. I try to create it by saying that. This might fail, and the only way I can deal with that is I catch it, right? If it fails, then I know, okay, if it's throwable, and if the throwable is an API exception, and if the code equals 409, then it was already there, and therefore it needs to be updated. So notice that I'm not looking at the old state. I'm not trying to reconcile anything. I'm just flat like recreating it, right? I'm doing an update. So here I'm saying API replace the deployment, right? So I tried to create it. It failed. I then did a replace. This is what you get when your error handling mechanism is a bunch of return codes from Go code, right? This is very much what I imagine a Go programmer would turn a Java API into. So there you go. That's the 3 use cases: delete, create, update, right? That's the business logic, and it's not great. In order to make this work, though, I needed a shared index informer and an apps v1 API. So that's this up here. That's apps1 v1 API. It needs the API client. I needed the shared index informer for the v1 foo type. That's the cache, the event cache of the data. And in order to get that shared index informer, I needed a generic Kubernetes API of v1 foo and v1 foo list. Okay, so that's this nonsense up here. I also needed the same thing for deployment, so I created that. So basically, lots of stuff I just wish I didn't have to worry about, right? It seems like a really good use case for auto configuration or some care at all, just anywhere. All of this does nothing, though, unless something runs it. So, of course, I've got a little application runner that starts all these shared registered informers, and it starts our controller, right? And it does so on a thread pool because it needs to run on a separate thread. And that's the entire bit of the code. The problem is, I want this to work in Kubernetes. And so I want this to work in a GraalVM context, right? I want to use native images. I don't want to have a controller that takes 500 megs of RAM when I'm managing a bunch of small apps that take 20 megs or 50 megs or 100 megs of RAM, right? My infrastructure shouldn't weigh more than my entire cluster. So we can turn this into a GraalVM native image. That's what we did here. So let's go back here, go to our build very, very quickly here. Actually, it's just over here. I'll just use that. Cat pond.xml. No. Cat pond.xml. pv copy. pom.xml. Here we go. Paste. So I'm just making sure I've got the right build. It's Spring Native. It's the hints library. It's all that. Then I'm going to compile it. Okay, so let's see here. Maven p native d skip tests clean package. And we'll just let that run in the background here. I haven't even run this for you yet, but you could just run it in your IDE. That's the nice thing about this. It doesn't need to be inside of Kubernetes. You don't need to package it into a container. You don't need to deploy. Just run it in your local machine, just like I'm going to do when I run the native version. Okay. That's the nice thing about writing these controllers. There's nothing mysterious about it. When you deploy it to the Kubernetes cluster, then you get questions around, well, do I want to have admin access to the API server? You need to set up RBAC. That's a whole other talk that could take another 5-10 minutes at least. But point is, it's easy enough to get 90% of the work working here. And if you look at this code, if you just use this, you realize that most of this isn't that hard. The business logic, well, the logic that I care about, is in this reconciler. And you can see it's pretty easy. Was it deleted? Handle that. If it wasn't, try to create it. If that doesn't work, try to update it. Pretty easy, right? Now you've got most of the common cases. So I'm just waiting for this to compile as a native image, okay? Fingers crossed. And we're using Spring Native hints. That's what that library, com Josh Long, oh, there it is, okay? So target, okay, oops, good. So did we actually, I don't know if we actually, did I do a apply? So it's watching. It started up in 44 thousandths of a second, right? And pgrep, oops, is that, and I can do my little PID equals this, and then Josh, env, bin, RSS by PID. So it's taking 63 megs, very, very small. You use Alpine Linux to deploy that, nice and easy. Okay, so let's actually try it out. So we've got it running. Nothing's happening. We're going to go to Kate's CRDs. We're going to apply test.yaml. So k apply -f test.yaml. Okay. There you go. So now if I go here, k get foos. 5 seconds ago, I created one called foo, demo 2, right? K get pods. Sorry, deployments? Is it deployments, right?
Yeah, do pods too.
There you go. 15 seconds ago. It created 3 instances of a deployment, programmatically. Okay? So, easy?
Understandable?
Understandable?
Okay.
Basically, it's not so hard. If I can do it, you can definitely do it, right? It's okay. It really isn't that bad. What we wanted to show you is that you've already got the tools today to do this, right? You look at all your friends having, it's not fun. What are the people that write Go code? It's not fun. What do they have? They have Go code. Look at all those people having Go code when you could be having fun, and you're like, I want to have fun, not Go code. Now you can write controllers too. That's the message here, people, is you can do this. You don't have to learn Go. Shouldn't learn Go. Nothing good will come of it. Thank you so much for your time. Who got something out of this? Who? Okay, rest of you. I'm sorry. We told you should have gone to Rawson's talk. Thank you.
Thank you.
Thank you.
Thanks.